Hello, everyone. My name is Elle. I'm the presentation manager from the Green Goblin Team, and today we'll be bringing to you our requirements and design concept demo. Before you go ahead and get into our documents, let's see the masterminds behind all of the hard work. Here is the Green Goblin Team. We have Nicholas, our project manager, Hilmi, the video manager, Andrew, our planning manager, Gerardo, the design manager, Zahar, the implementation manager, Leah, our webmaster, Elle, myself, the presentation manager, Samir, the collaboration manager, Jonathan, the documentation manager, as well as Jake, the testing manager. So what will you be viewing today during the requirements and design concept demo? You'll be seeing our planning documents, the requirements documents, as well as the testing documents. So without further ado, what we've all been waiting for, let's get into those planning documents. Samir, take them home.
Thanks for the introduction, Elle. Hello, everyone. My name is Samir. I am the planning manager for the Green, and I'm just going to show you our overview for our project so you can see from start to finish how we are going across this. So these are our dependency graphs. So as you can see for our overview, planning goes all the way down to project submission. Everything to the right of the yellow is what is required in order to fulfill the yellow. So you can see a gathering requirements all the way down to project kickoff. Milestone 1, you can see set a remote repository, cloud architecture setup testing. Same with milestone 2 and 3. You'll notice milestone 1 and 2, there are epics stacked on top of each other, meaning they could be ran in parallel and be done at the same time, so we can save time and work more efficiently. And then to the right is a breakdown of our technical, showing us that after we set a remote repository, milestone 1, what is needed exactly after, and what things under that can be done at the same time. And then after that is done, we can go down to database setup and then database utilization, and eventually to milestone 3. Next, I'm going to show you our critical path. Critical path is basically the minimum amount of time needed for our project to be done from start to finish. Originally, we sat at 27 days with 648 hours. And if we remove project kickoff, theme leaf setup, UI, UX testing, and front-end optimization, we go down to 20 days, which is about 480 hours. So we save about 7 days. And so if we were under the gun, we can get our work done more efficiently or quickly. Next, I'm going to show you is the software that we use. We use Jira that allows us to create epics, tasks, tickets, dependencies, and all these things that are within our project. And Planaway is integrated within Jira that consolidates all that information and puts it into a calendar format that is easy to read and use. And that's what I'm going to show you guys next. So here on Jira, we're within our Planaway, as you can see right here. And within Planaway, we have a calendar view, so we can see from the start date of September 12th, pre-project things. And then as we scroll down, we can see milestone 1, everything under milestone 1 is what is required or what has been done within milestone 1 dates. And we can hover over and see September 19th to 24th. And then we can keep going. Same thing with milestone 2, everything under that. This includes milestone 1. And then milestone 3 as well. And then all the way until we get to October 8th, which is our project submission. So we want to see a more broken down view. We want to see who specifically worked. Like we have these little icons here that tell us like, oh, AY, that's Andrew, or like this one right here, JP started from September 19th to 24th. We can see every epic under it. And we can see exactly specifically what people did on those dates. But today I'm going to be focusing on 2 people, which is Jonathan and Jake. Jake is our testing manager and Jonathan is our requirements manager. So if we go to users here and we basically just untick everything besides them, we are able to just see specifically what they did. And so with milestone 1, we can see that Jake was just doing some side tickets. And then also, since he is our testing manager, he was involved with setting up the remote repository. And with Jake, we can go into milestone 1. We can see that these are our epics that we were talking about earlier. And you can either click through here or you can just click them right here. And then you can see our dependencies. So we can go back to our first epic. Here's our dependencies. And these are all the tasks that are required in order to make setup a remote repository fulfilled. And if we go to the second epic, cloud architecture setup, it's the same thing. Here we have a bug, meaning that replanning needed to be taken place. So when Jake was creating Elasticsearch Bean application, GOB53, but then a problem happened in which we need to address instantly. So in order to move forward with our tickets, we needed to reconfigure. And then we can also hover over here to see the problem, what specifically happened with it. And then on towards Jonathan, we can see that Jonathan is our requirements manager. So his dates were slightly different, but they all fulfill milestone 1, milestone 2, milestone 3. And we can just drag it by here. We can also show a better view if you wanted to look at more weak. If you want to see a more broken down setup, you can see it like that. And then this also applies if you have more users, you can keep scrolling. But for this one, since we see John, and we can see that his gathering requirements started on January 12th, and then we keep going and going and going. And then there he is, and we can even zoom out even more so we can get more dates. So milestone 1, we can see that he was there and he created other tickets such as his work log. And when we click on the gathering requirements, we can see its dependencies, which are the work logs, and it says exactly what he did. And we can keep going for these ones as well. And it just allows us to see exactly what people are doing. We can show everyone again, and anything that we have questions on, there communicate. But that is about it, guys. I'm gonna pass. What I also wanted to show is that in Planaway, we can see that everybody has their own personal tickets. For example, we see a couple personal tickets from Jake and then a couple from Jonathan. If we were actually to click on these personal tickets, we can see that they have a team assigned, an estimated amount of hours that we think it'll take, but in reality, this one took an hour. And then we have a due date, just soft due date, and then that is how we would keep information categorized, and all the information is just consolidated in one place so we can keep up with it. And then that was for Jake. We can go to Jonathan within his gathering requirements epic. We can see there's a child issue, which we'll click on that, and that has the time estimated in terms of the due dates. The hours also has a requirements team. And this consists of Leah, Andrew, and Jonathan. So it also lets us know like who's working on what, so we can keep track of things easier. For example, like we went to like a different ticket, like for example this one, we see it's assigned to a technical team. It also has an attachment, so adds more visuals to help with understanding. And then another cool thing is that when you see the technical team, you can also click on the profile, in which you can see everything that our team has done. Well, these team members, specifically the technical team. And if you wanted to locate something specific, you would just click show more. If it's something big and then something specific, you were able to just go down, and you can just keep going down and see everything for more specificity. But yeah, hopefully that was able to get off to our requirements manager, Jonathan.
Thank you, Planning Manager Sam, for the great presentation. Switching roles to requirements. My name is Jonathan Paez. I'm the Requirements Manager. First, I want to talk about the roles of the Requirements Manager and the importance of requirements. We'll go over some of the points, not all of them. So, the roles of the Requirements Manager. Pivotal in guiding the group project. Essential tasks include creating the formal requirements document, spearheaded the RDP demos requirements section, crafted detailed formal requirements of teams of our own. So now the importance of clear and organized requirements for project success. Clear requirements provide a roadmap for developers, function as a guide specifying what needs to be built. Moving on to what I will be showing, the documents I will be showing today will be the tech requirements / history document, which will entail functional requirements and their relevance, system requirements, why they matter, external interfaces, what they entail, state mode considerations, environmental requirements, why they're crucial for deployment, and some of the tech testing. It would take forever to go through each one, so today I'll just be showing the functional requirements and some of the tech testing. So we have other documents like non-tech requirements, non-tech tasks, but today I want to focus on tech requirements in history and tech testing. So first and foremost, just on the functional side of requirements, if we look at tech testing. So first and foremost, just on the functional side of requirements, if we look at Rec ID 1, we have the requirement is draft primary web pages using basic HTML structures. And more on an HTML side, we needed to have a document structure with our doc type declaration. There was of course a head section where we could add our catchy Green Goblin's e-commerce title. We had a header section which we were able to use to get our website logo, our Green Goblin's website logo, and of course a main content section where we would feature our pages like our men's section, our women's section, kids section, more like a featured products type of thing. So for a more clear description of our requirement, we have a create a home landing page, individual product page, temporary navigation bar, product categories page, checkout page, confirmation page, login page, and account page using HTML and CSS. So we also have bad client. We also have a bad client and bad dev part, and a solution to the bad client, bad dev if any of this were to occur. So for bad client, we have changes the design frequently, provides an unclear feedback. And for bad dev, we have use non-responsive design, disregards accessibility, writes unorganized code. And our solution for this would be a hold a kickoff meeting to clearly define the design scope and set boundaries for changes. Implement a change request response, educate the developer about responsive design, and organize code reviews to ensure adherence to best practices. And of course, all these were signed off by our testing manager, Jake. Switching gears to tech testing, if we look at Rec ID 1, which is also they go hand in hand with if we look at Rec ID 1, which is also they go hand in hand with requirement 1, which we just saw. So first, I want to go 5 users will try to open all different pages. Result, success. All 5 users were able to view all different pages. Approved, our test state. Comments, which is test of navigation of all pages functional and all HTML loads properly, and signed off by our testing manager, Jake. Revision 2, 5 users will test out if the product buttons are functional. Success. All 5 users were able to click on a product image or product title, and it led them to the product page. Approval, yes. Test date, comment, test the product images title, images/title, titles lead to product pages. Again, sign off by Jake. Version 3, 5 users will be able to use the navigation bar and lead them to different pages. Success. All users were able to use the navigation bar to go to different pages of the website. Approval, yes. Date. Our comment was test of implementation of navigation bar. Again, signed off by Jake. So these are just two of the sides of the many requirements that we have to offer. Now I want to. These are just two of the sides of the many requirements that we have to offer. Now I want to switch it off to our testing manager, Jake.
Hi everyone, I'm Jake Opie from the dev team, and I'm going to talk about our software design and implement. First up, I'd like to talk about data storage, which includes our database schema, our disk files, and our key data structures. So here you can see a diagram of our schema, which includes tables for orders, users, inventory, cart, products, and categories. The user ID helps connect users to their orders and their cart, and the product ID helps keep our products organized in our inventory and organized into categories for the customer. The database is easily scalable, as different fields can be added to each table and versioned with our Flyway system that I'll talk about later. In terms of our disk files, we use a PostgreSQL. All of our app versions are stored in AWS 3. This integrates with our CI/CD pipeline we've implemented, which allows us to rapidly redeploy old versions if a new version isn't behaving as expected. We use GitHub to host all of our source code and our pipelines, and we use a Redis cache engine on AWS Elasticache for quick fetching of user sessions and cart information. Talking about some of our key data structures, our application is built upon the Spring MVC framework, which involves a few key data structures. The Spring controller decorator indicates a class that handles REST routes and methods, so get, put, post, and delete. And methods within these classes will be bound to subroutes, which are invoked when the path is accessed. The repository annotation is used for our JPA and our database connections, and the model classes are used for certain just plain old Java objects that are storing information within our application. A JPA entity indicates a class that represents a table in our database. So each table that you saw in the schema will have a corresponding JPA entity in our source code, and DTOs or data transfer. Here you can see an example controller class in our MVC framework. Use the controller annotation on line 7 to indicate to Spring that this is a controller and will be accepting requests within our application. The get mapping annotation on line 11 specifies at what URL this resource will be returned, and here we're returning the string home, which Spring knows is the name of an HTML file. Now I'd like to talk about security, deployments, and client-server protocols. First up is security. Inherently with an e-commerce application, security is a key concern. You have payment information, you have addresses, you have passwords, and then we have all of our development secrets that we use to make this thing run. So first up, our credit card details are not being stored in our database. We use Stripe to broker payments, and they are certified by the payment card industry, and they have top security compliance marks, and they are checked every year, and this certification needs to be renewed every single year. So security is in good hands in terms of payment information, and card information is never stored. As for customer password encryption, we use bcrypt, which is a hashing algorithm designed for encrypting passwords. It's a one-way hash function, so once a password is encrypted, it can never be decrypted. This means that our team can never see your password and no hacker can ever retrieve your password. The algorithm is actually a little bit slower than other hashing algorithms, which is really helpful in brute force attacks, as it'll take hackers extra time to try and figure out a user's password, making it virtually impossible. As for product level information, we use GitHub secrets. So all of our environment variables connecting us to Stripe APIs or AWS resources, they're all within our GitHub environment, and they are never explicitly stated in our source code and never passed in HTTP requests. As for deployments, we started with a manual deployment process where we were creating jars via the command line and then uploading them to AWS Elastic Beanstalk, and then we'd have to manually check that deployments were successful. Instead of that process, we implemented a pipeline using GitHub Actions to trigger on a merge to our main branch. So after our code review, we merge our development branches into our main branch, and this triggers our deployment pipeline, which pushes out new updates within minutes. So before we get started diving into that deployment pipeline, I'd like to note the color-coded blocks that correspond with each portion of the pipeline being explained. You can see the text on the right talking about each stage, and then you can see a block on the far left highlighting what code corresponds to that stage. So we can see in the first stage, we're just declaring the name of our pipeline, some environment variables like what version of Ubuntu we're running on, And then we move on to the second stage where we pull the main branch from our GitHub repository. This is done with an inbuilt action that GitHub provides. Next, we set up our build JDK to mirror what we're doing in our local development environments. And then we build our production profile in Spring using some of those GitHub secrets that I mentioned, like our database username, our database connection string, and our database password. In the next portion of the pipeline, we're creating our jar with Maven. As I mentioned, we did this manually beforehand, but with this one command, we can do this using our prod profile that we just built, and we can make the same package that we would manually automatically. In the next stage, we're configuring AWS credentials using an AWS provided action. We pump in our access keys and our region, and we are all set up to push new code to our S3 bucket. We upload our jar to our S3 bucket in the next stage. This is where all of our application versioning is happening. So if we need to revert a version, this is where it's all being located. Every single commit to the main branch is being built into a jar and then put into this bucket. In the second to last stage, we create a new Elastic Beanstalk app version to prep for deployment. We tag it with a GitHub commit hash to ensure we can version easily with our backend services. And then in the final stage, we deploy this new application version to our EC2 instances with the same version labels. In terms of client-server protocols, we have a few mechanisms at play. Standard HTTPS requests are made with external services such as OAuth2 login requests and Stripe payment validation and processing. Spring MVC handles all calling of internal endpoints and services within the application, and AWS provides seamless integrations with its own services like the email service we use, the relational database instance that we're using, or the Elasticache instance. Here you can see a diagram that's detailing some basic client-server protocols when requesting products via category. The client queries the server, which pulls products from the selected category from the database, returns them to the server, and this populates our HTML pages dynamically using our Timely framework that we've implemented. Finally, we have data flow. So I'm going to talk about high-level design, data flow overviews, and data flow diagrams. Here's a high-level architecture diagram of our entire project. You can see how all of the modules interact with each other and where different processes are carried out. For example, in the top right, you can see our CI/CD pipeline. In the diagram, our source code is pulled from GitHub on push to the main branch, upload to our project jar S3 bucket, which is then deployed to the Elastic Beanstalk environment, which creates a new app version and sends updates to our team via AWS SNS. This diagram encompasses everything in our system, including our backup systems and all of our external APIs like Stripe. Here we see our level 0 data flow diagram. We can see interactions between our users and our site, and then our site and the backend. As shown in the slide before, this is much more complex under the hood, but this is more of a high-level diagram so anyone can understand what is going on behind the scenes. In our level 1 diagram, you can see a more complex view of the data flow. You can see the login module and the order module have been separated, and they both interact with the user for different functionalities, and they both fetch information from the database and write information to the database. Cloud services has been separated as well. This includes our email notification system and our Stripe payment validation system. And then finally, in our level 2 diagram, we see an abstraction of the backend layer and the application layer. You can see what requests are made to the front end, which are then passed to the backend for validation, such as login requests, posting of user orders, retrieval of user info, payment validation, order notifications, and such things. Now talking about hardware, we can get into hardware specifications and our backup systems that we've implemented to increase uptime. So we use EC2 instances to host our application. This is all on AWS. They run on an Amazon Linux version from this year, which is optimized for EC2. We use T3 micro instances, which offer 2 virtual CPUs, 1 GB of RAM, 5 gigabits per second of bandwidth. And the cool thing about these EC2 instances is they can adjust to spikes in demand. They can exceed 100% compute power because of the virtual nature of the CPUs, meaning our application will never be unable to hand extra load and will never be throttled. So our tech stack includes Java 17, the Spring Boot framework, which is handling all of our MVC functionality, vanilla HTML and CSS, PostgreSQL, JPA, and Flyaway for database migrations. Maven is our build tool and dependency management tool of choice. GitHub is hosting our source code and our pipelines. AWS is our cloud provider, and Stripe is our payment validation service. In terms of backup systems, I'd like to hammer home these concepts to ensure you understand our reliability. We have a version rollback pipeline that we've implemented using GitHub Actions. This takes the most recent working version of our application from the S3 bucket and deploys that jar to our EC2 instances. This means in case of
Thanks for those testing documents, Jake. Now you heard from everyone from our team, and that concludes our requirements and design concept demo. Thank you so much for your time, and thanks for watching.